fasting for 24 hours isn't a punishment for your digestive system. It's the only real rest your internal organs get after decades of relentless, nonstop activity. During those 24 hours, something miraculous happens inside you. Your liver quietly transforms into one of nature's most sophisticated fuel management systems. Your heart becomes more efficient and electrically stable than it was years ago. And your brain discovers a superior energy source that leaves you more alert, focused, and clear-minded than when you're full. Today, we'll explore each of your body's major organs during a 24-hour complete fast, examining the precise function of each organ as you allow it to recover. From 0 to 4 a.m., the stomach begins to rest. The stomach is the organ that causes the most anxiety for many people when fasting. For the first 4 hours after the last meal, it remains highly active, contracting rhythmically and secreting acid to break down remaining proteins and fats. This is the familiar state of a digestive system trained to work almost continuously. During these first few hours, the stomach continues to produce digestive juices even as the amount of food inside gradually decreases. This is perfectly normal. Years of habitual eating have trained the stomach to receive food regularly, so it continues to prepare for a further decrease in food intake. But around the third hour, something begins to change inside. The vagus nerve, which serves as the primary communication pathway between the brain and the digestive system, begins to stabilize. The continuous state of readiness for digestion characteristic of satiety begins to gradually decrease. Stomach acid production slowly returns to normal instead of surging in preparation for the next meal. The stomach experiences true tranquility between cycles instead of immediately preparing for what is to come. Around the fourth hour, hunger hormones like ghrelin increase, creating a distinct feeling of hunger even though the body's energy reserves are still abundant. This is the nervous system's reaction to the disruption of a familiar eating schedule, not a sign of energy deficiency. In fact, this unpleasant feeling marks the beginning of a crucial transitional phase, when the entire metabolic system begins to prepare for deeper mechanisms beyond mere hunger. Hours 4 to 8, boldness forward. The liver rarely receives the attention it deserves in discussions about fasting, but it's undeniably a central figure in this story. Imagine your liver as the operations manager of a massive logistics facility. In the hours following your last meal, it's busy taking in energy sources, converting excess glucose into glycogen, and storing it in liver cells as a strategic fuel reserve for later use. But around the sixth hour, the dynamics shift dramatically. With no more fresh energy from digestion, the liver realizes it must shift from receiving and storing to managing and distributing. It begins breaking down stored glycogen and releasing glucose back into the bloodstream in a controlled and regulated flow, ensuring the brain and other vital organs continue to receive a steady and reliable energy supply without interruption. This is where the liver truly demonstrates its extraordinary ability. Instead of releasing everything it contains at once, it carefully regulates the amount of secretions released, acting as a precision delivery system, providing exactly what the body needs at the right time. Blood sugar levels stabilize. Organs are supplied with sufficient energy, and the rest of the body continues to function without any significant disruption. But the liver doesn't stop there. When glycogen stores begin to run out, it activates a process called gluconeogenesis, essentially becoming a biochemical producer. Using raw materials including amino acids and other non-carbohydrate compounds, it synthesizes new glucose from scratch. It produces usable energy from raw materials not originally designed for fuel, keeping the entire system running even after reserves have been depleted. Hours 8 to 12, the pancreas rests. For years, the pancreas has responded to every meal, every snack, and every fluctuation in blood sugar by releasing rapid amounts of insulin. Imagine insulin as an overloaded traffic controller at a constantly congested intersection, continuously directing the flow of sugar molecules to their intended destination. The pancreas has been performing this task without any real rest since regular eating became a habit. When no new food enters the body and blood sugar levels stabilize at lower and more consistent levels, the pancreas will eventually reduce its activity. Insulin secretion drops to a minimum. And this is not a warning sign. This is precisely the recovery state the pancreas needs, similar to a muscle that has been under constant stress finally being released and completely relaxed. When insulin levels decrease, something truly beneficial begins to happen in cells throughout the body. They become more sensitive to insulin. The principle here is similar to what happens with sound. After prolonged exposure to loud noise, the ear adapts and sensitivity decreases. But after a period of quiet, even small sounds are heard clearly. The same mechanism applies to insulin. Lower exposure to insulin allows cells to become much more sensitive to smaller amounts of insulin. And this improved sensitivity is one of the most clinically significant benefits that regular fasting can provide. By the 10th hour, the liver has entered a new phase of activity, simultaneously maintaining blood sugar levels through the reserves it produces and stores, while beginning the initial stages of fat processing. This metabolic flexibility, the ability to smoothly switch between different fuel sources and management modes, is one of the defining characteristics of human physiology and one of the main reasons humankind has survived the prolonged periods of food scarcity that have shaped us. Hours 12 to 16. The heart rediscovers its rhythm. Many people worry that fasting will put strain on the heart, but biological evidence suggests the opposite. During periods of fasting, the cardiovascular system is not overloaded, but gradually becomes more efficient and stable. Between the 12th and 14th hour, insulin levels drop sharply, unlocking the body's fat-burning process. Fatty acids are released from adipose tissue into the bloodstream, becoming an alternative fuel source for organs and reducing reliance on glucose. This transition is smooth and in line with natural physiology. One early and noticeable change is that blood pressure tends to decrease. When insulin is low, the kidneys excrete excess sodium and water, reducing circulating fluid volume. The heart therefore has to work less to maintain circulation, and the pressure on the blood vessel walls also decreases. The long-term mechanical burden is gradually relieved. Simultaneously, heart rate variability, or HRV, is often improved. A high HRV reflects better nervous system adaptability and more robust cardiovascular health. During fasting, the parasympathetic nervous system, which is associated with rest and recovery, is more active, creating a more stable and balanced cardiovascular state. The heart also becomes more electrically stable. Contrary to popular belief, the risk of arrhythmias does not increase but tends to decrease, mainly due to the reduction of systemic inflammation in the cardiovascular system. A less inflammatory environment helps the heart's electrical activity become more consistent and easier to control. Around the 15th hour, the stomach has been empty for some time, but continues to secrete acid and enzymes according to its familiar circadian rhythm, creating a gnawing or mild cramping sensation. This is not a sign of damage, but a pre-programmed biological process. When the stomach has enough time to rest, the inner lining has a chance to recover and inflammation subsides. Eating continuously, especially late at night, often disrupts this process. Studies show that controlled fasting can reduce inflammation along the digestive tract, and some people with gastritis or irritable bowel syndrome report symptom improvement. Even when empty, the stomach doesn't stop working. It's repairing its surface, adjusting its chemical environment, and preparing to function more efficiently for the next meal. Hours 16 to 20. The brain changes fuel. This is the most surprising stage for many people. Around the 16th hour, the brain begins to gradually switch from glucose to ketones as its primary energy source, a fuel produced by the liver from stored fat. For many, this is the first time the brain has operated for an extended period using this alternative energy source. Ketones are high-performance fuels for the brain. They produce less oxidative stress, offer more energy per unit, and generate fewer metabolic waste products than glucose. This explains the characteristic feeling of alertness and clarity that many people experience during prolonged fasting. The brain isn't lacking energy. It's simply operating with a more biologically suitable fuel source. Ketones also strongly stimulate the production of BDNF, a crucial factor for the survival, repair, and formation of new connections in neurons. During this phase, the brain not only adapts but also strengthens its own structure and functionality. Simultaneously, the brain increases the secretion of norepinephrine, a neurotransmitter that enhances concentration, alertness, and information processing speed. From an evolutionary perspective, this makes perfect sense. In the context of food scarcity, humans need to be more perceptive to survive. Therefore, cognition is designed to improve during starvation, not decline. From around 18 to 20 hours, the body enters a period of intense fat burning. Stored fat is broken down into free fatty acids to provide energy for most tissues. The liver converts some of these fatty acids into ketones, maintaining a steady fuel supply for the brain. By this time, ketones can provide nearly half of the brain's energy needs, which is why fasting is of interest in research on neurological diseases such as epilepsy and Alzheimer's. From 2000 hours to 2400 hours, the cell cleansing process begins. We've reached what many researchers consider the most crucial stage in the entire 24-hour process, a cellular event called autophagy. This is the phase where individual cells in every organ of the body begin a comprehensive internal cleansing and recycling operation, an activity simply impossible when the body is actively digesting and processing a constant supply of food. During autophagy, cells systematically identify damaged proteins, aging organelles, and accumulated cellular debris. They encapsulate these materials within specialized membranes, forming compartments that then integrate with the cell's internal breakdown machinery. The internal components are broken down into basic molecular components, which are then immediately reused as raw materials to build new, complete, and fully functional cellular structures. This process is occurring simultaneously throughout the entire body. Liver cells are breaking down and replacing damaged or underperforming mitochondria. Heart cells are removing accumulated protein clumps that, if left to build up over time, would impair heart function. Brain cells are removing misfolded proteins associated with neurodegenerative diseases. Every major organ is undergoing an internal renewal process, and each organ is replacing old and damaged parts with newly assembled ones. This is the biological basis for why fasting is sometimes described as a process of cellular rejuvenation. You're not simply giving your organs a rest during this time. You're allowing them to replace damaged internal components at a molecular level, a process biologically impossible with continuous eating because the cellular machinery is already preoccupied with processing nutrients and cannot simultaneously perform maintenance. Regenerating the digestive system. Around the 23rd hour, the gut microbiota begins to restructure. As the continuous supply of nutrients ceases, some bacterial strains decline in number, while those well adapted to the less food-rich environment become more dominant. This change doesn't just affect digestion. Studies show that fasting can increase the diversity of the gut microbiome, a factor linked to stronger immunity, more efficient nutrient absorption, and lower levels of systemic inflammation. A diverse microbiome also helps limit the growth of harmful bacteria. Simultaneously, the digestive system utilizes this time to strengthen the intestinal barrier. The intestinal lining acts as a selective filter, preventing toxins and pathogens from entering the bloodstream. When not interrupted by continuous eating, the lining has time to recover and enhance its protective function. Even when the stomach and intestines are nearly empty at the 23rd hour, the digestive system doesn't take a break. It's performing deep maintenance tasks, jobs that a continuous diet wouldn't normally allow to be completed. A surge in growth hormone and muscle protection. After about 24 hours of fasting, a noticeable hormonal change occurs as human growth hormone surges, often reaching about 5 times the normal level. This is no small fluctuation, but a pronounced biological response that directly affects how the body manages and regenerates tissues. Growth hormone, HGH, promotes muscle recovery, increases the mobilization of stored fat for energy, and supports widespread cell regeneration. This combination is why prolonged fasting is often considered a favorable state for recovery. Notably, the increase in HGH occurs entirely due to the physiological conditions of fasting, requiring no exercise or external stimulation. This hormonal response also helps address common concerns about muscle loss. While it's intuitive to think that not eating will deplete muscle mass, the body actually prioritizes the use of glycogen and fat before accessing protein from muscle tissue. The risk of significant muscle loss only becomes apparent when fasting exceeds 24 hours. During this phase, HGH plays a role in protecting lean tissue while simultaneously accelerating the fat-burning process. Some individuals may experience a slight decrease in endurance or performance during exercise, but this is primarily due to a decrease in muscle glycogen levels, affecting the ability to generate energy quickly rather than a loss of muscle mass. It is the combination of muscle preservation and fat loss promotion that has led many athletes to adopt intermittent fasting, realizing that these two seemingly contradictory goals can be achieved simultaneously under the right physiological conditions. 24-hour milestone. Achievements and things to watch for when you reach the 24-hour mark. You've crossed a critical biological threshold. At this point, the body switches entirely to fat burning. The ketone-producing system stabilizes, and deep cellular maintenance mechanisms are activated across most organs. This is a biological state that most modern humans rarely experience, simply because food is always readily available. However, fasting is not suitable for everyone. People with diabetes, cardiovascular disease, liver or kidney disease, or metabolic disorders should not fast for extended periods without medical guidance. Pregnant women, breastfeeding mothers, and those with a history of eating disorders are also not suitable for this method. Even for healthy individuals, a 24-hour fast should only be undertaken with adequate preparation, a thorough understanding of the body, and careful monitoring of physiological responses. Throughout the fasting process, listening to your body's signals is crucial. Unusual signs such as severe dizziness, chest pain, or a noticeable feeling of exhaustion are signals to stop. Fasting is a form of biological stress that is beneficial when within adaptive limits, but becomes harmful if it exceeds an individual's tolerance. An important factor that cannot be overlooked is electrolyte balance. When insulin levels drop, the kidneys increase sodium and water excretion, leading to a risk of mineral deficiencies. Adding a small amount of quality salt to drinking water helps maintain nervous and cardiovascular function and reduces headaches. Magnesium is also particularly important because the brain, heart, and musculoskeletal system all depend on it. Ensuring sufficient magnesium before and during fasting helps the body maintain a stable state. For those who practice 24-hour fasting regularly and consistently, the benefits are not immediate but accumulate gradually over time. The liver manages metabolism more efficiently. The heart maintains a more stable circadian rhythm. The brain maintains better cognitive function. The gut microbiome is more diverse. The kidneys filter waste more effectively, and the immune system is regularly renewed. These are not short-term changes, but sustained improvements in fundamental systems. Internal organs are not fragile structures that need constant nourishment to prevent damage. They are the result of millions of years of evolution in environments with scarce food. Fasting for 24 hours does not deprive them of what they need, but allows them to function according to their designed biological rhythms. The stomach lining recovers. The liver assumes its central role in coordinating metabolism. The heart optimizes its rhythm. The brain utilizes cleaner energy sources. The kidneys eliminate excess fluid, and the immune system restructures its cellular components. This is not a physiological crisis, but a coordinated, orderly response. Therefore, when someone claims that fasting is harmful to internal organs, it usually stems from a misunderstanding. Organs not only withstand 24 hours without food, but they also utilize that time to become more efficient, more resilient, and function according to their core biological functions. If exploring what your body does throughout a day without eating or drinking helps you better understand the hidden intelligence in your own biology, consider liking this video, sharing it with someone who might benefit from this understanding, and subscribing to the channel so you can continue to follow along as we learn about the science behind the daily choices that shape your long-term health.